Okay, is that all we got? Still missing several people. All right, well, good afternoon to those of you that are here. Today we've got answers to go over, more problems to try out. No, excuse me, do or do not, there is no try. Okay, so you will do the problems, not just try. It's about attitude, right? What attitude are you going into it? Don't just think, I'll try, it's whatever, maybe. No. Positive attitude. Go in, mission to do. So with that said, let's start by taking a look at answers to the previous problem set, the first set, and then hopefully you can use that information to help you on today's part 2. So here we go. First up we had naming all the line segments. Okay, so you're looking for end-to-end point. There were 10 of them total. Here they are. Every combination, AB, AC, AD, AE, BC, BD, BE, CD, CE, and DE. Similar to the handshake problem, right? Everyone has to combine with everyone at least once. And of course, AB is the same as BA, which is why you don't need to repeat it, right? Next up, we had points on a line. They gave you the exact locations. You were to find the distances between them. So this is pretty much subtraction. Actually, this is just a subtraction exercise, okay? But very important, right? Something as simple as, second grade arithmetic is part of the foundation of geometric design and problem solving, okay? Very important there. So there's the lengths there. A was 4.34, B distance of 1.91, C is 6.65, and D is 4.22. And then next, similar to the line segments, now we are naming all of the angles found in the figure. So we could have the small one on the top here, BAC, or you could call it CAB. You could go backwards, okay, reversing the order there. Doesn't make a difference. We've got the large angle, BAD, and then the second small angle, CAD. Notice that all of them, they still have A as the center. It is the vertex. The vertex has to be the middle letter. Otherwise, you can go whichever order you like. And then the two adjacent angles would have to be the two small ones, BAC and CAD. Any questions on the first page there? No? All right, let's go on. Number 11, how many different angles less than 180? Oh, so we're not counting the reflex angles around the backside, right? Are shown. There are a total of 10 possible combinations, and again, that's going with like AOB versus AOC versus BOC, right? All those. 10 of those total, 4 of them will be obtuse, and 6 of them will be acute. For number 15, here now we've got the finding of angle measures. Determine the measure of these angles without a protractor. So you're not literally measuring it, you're going to calculate it. So we know BFC, that's this guy here. Let me add one more arc there to make that clear, right? This is 55, okay? This one is 150, and this is 120, and then of course the whole thing, AFE, is 180. So you're going to subtract, to find AFB. So you want this arc in here. Well, that's 180 minus the 120, right? And then once you have that, you can subtract the 60 and the 55 from the 150 to get CFD of 35. All right. And then finally, 2 lines in the plane divided up into 3 regions if they're parallel, 4 if they're intersecting. So we want to find what is the maximum number of regions you can create for a given number of lines. And based on that example alone, it should be somewhat apparent that you're going to aim for intersections. You want intersections. Will give you more regions than parallel lines. The maximum possible, as it turns out, for 3 lines is 7 regions. 4 lines is 11 regions. 5, 16, 10 will give you 56. What's the pattern going on here? It's almost the triangular numbers, but one bigger, right? It's n times n plus 1 over 2 plus 1. One more than the triangles, right? Because we had, instead of 3, 6, 10, we had 4, 7, 11. One more than the triangular numbers. So again, this little formula, that little expression, n times n plus 1 over 2, super duper handy. Shows up all over the place. Learn to love it. All right, that's it for the level 1s. Any questions? No. All right, then let's run through the level 2s. Okay, starting off with, how about rays in the same diagram? Okay, well, rays, I cannot just reverse the letters here, but I can reverse the arrow. So ray AB is different from ray BA. I have the arrow going in the same direction. Or I could have reversed it so that the arrow is over the A. So this is a different ray than that one. This is the same as this guy. So there are 8 different rays there. Here we have some kind of polygon, quadrilateral. Find the angles with Q as a vertex. So that would be PQR, or you could reverse the order and call it RQP. PQS and SQR. The 2 pairs of adjacent angles are going to have to be these ones in the middle, right, that share a side there. So you have PQS and SQR over here, and PSQ and RSQ over here. For number 12, if TSW are collinear, that is to say this is a straight line, then there are 6 different angles represented in the diagram, 2 of which are obtuse. That would be, you can do this one or this one, right? And these supplementary angles, you could have WSV plus VST. You have this big one plus the little smidgen there, or WSU plus UST. And then another, calculate the missing angles here. We are given BOD is 72, AOD is 150, and then AOC is 90. So to find AOB, again, you're just going to subtract what you know from what you are missing. So we have this hole is 150. This is 90 to here, so you can find COD with a straight subtraction there. And then B would be the 150. Well, this would just be 150 minus the 72, right? There. And then B for BOC, you need to find COD first and subtract that from the 72. And COD is the 150 minus 90. All right, and 18, similar kind of, except they don't really give you the measurements directly. We know from the diagram 1 and 2 add up to 90 degrees, and we're told angle 1 is 14 degrees less than twice the measure of angle 2. If they don't tell you something directly, and it sounds like, well, that's a very roundabout way of hinting at what it is, you know, giving this hinting of a relationship, but using more numbers than it sounds like they're reading out an equation. So that's a very good hint that you should set up some variables and just write equations. To solve this, you will set up a system of equations and then solve the linear system. Right? And you will find angle 1 is 55.33 and angle 2 is 34.67. Okay. Questions for level 2? All right, then on to level 3. Here we have distance on the number line again, but now we're dealing with the radicals, right? Square root of 2, which actually I find it turns out much simpler not having to deal with the decimals because it's all whole multiples of square root of 2. So let this be a little preview of Algebra 2 for you, where you're going to have to get used to the radicals, right? They're just going to be everywhere. Get used to them. Treat them nicely. So there's the lengths there, 6, 5, 2, and 9 root 2s. Number 19, again, very indirect. These angles are complementary, but A is 4 times as large. Like if they're writing out some kind of relationship that way, write an equation, solve the system. Angle A is 72 degrees. Number 20, same way, set up system of equation. 9 more than twice the measure. Okay, so y times 2 plus 9 equals x. Write that down. Right, solve the system. X is equal to 123 degrees. And finally, we have, similar to how the lines will carve up the plane, we have how the points can create a bunch of lines. So you can take 3 points, put them in a row, get 1 line. Or if you spread them out, the most you can get is 3 lines from 3 points. How about 4 lines? 5 lines, right? What's the pattern here? So 4 points gives you 6 lines. 5 points gives you 10 lines. 6 points for 15. And the pattern here is similar to, but not based on the triangular numbers. So instead, it's n times n minus 1 over 2 instead of n plus 1. Right? So to get 6, you'll take 4 times 3, it's 12, divided by 2 is 6. Yeah? Okay, questions for level 3? All right, then you have there's nothing else that we need to do for today, so you have the rest of the period to work on problem set number 2. These ones are a little more problem-based. They'll more closely resemble the latter half of this problem set than the beginning. This one I kind of included what would probably be considered some exercises, right? Some simple things like name these and find the distance there. That's not really, you don't need the problem-solving strategies to answer number 7. But you will be implementing more strategies in the problem set for today. Okay, so I will be on standby to answer any and all questions. Ready, go.